Another of Mr. Wagner's Math Help. I got a couple questions today about the homework, and there were multiple questions, but I think if we just go over some basics about graphing equations, I think it'll really help everyone out. So let's look at this problem. This is problem 11, part A. So I want you to graph this pair of equations. As we've been talking in class, we know the three different forms of equations. And this form, as we all should know by now, is the slope-intercept. And the reason we call it the slope-intercept is because this coefficient next to x is the slope, and this number is the y-intercept. We've talked about this a lot in class. I'm not really going to go over all the details about the y now. But keeping that in mind, this slope-intercept form makes it really easy to graph most equations, because right away I know that my y-intercept is 1, and that's when x is 0, by the way. So when y is 1, x is 0. Now the slope is 2. We know that the slope is 2. So with the slope being 2, that's really saying it's 2 over 1, because we need a fraction here for rise over run. That's really poorly drawn here. Let me try this again. Slope equals 2 over 1. Alright, so if I rise 2, go up 2, and go over 1, I now have 2 dots. And with these 2 dots, I can now graph the equation. Just make my line go right up here. It's as straight as I can really get it. And then, ooh, that was bad. This next point is going to be down here. So, something like that. My writing utensil doesn't really work well in Paint, I'm finding out, but I'll continue anyway. So that was a really easy one to graph because we already had it in y equals mx plus b, or slope-intercept form. Now, what are we going to do about this one? My suggestion, what I would do, is I would turn it into y equals mx plus b form. So right now it's in standard form. We have both of the variables on one side, and we want to get y alone. To get y alone, we have to subtract 3x from this side. Yeah, see, this is messing up. And 3x from this side. So when I do that, y equals negative 3x plus 1. Now we have it in our y equals mx plus b. That is an equal sign. So once again, the y-intercept is 1. So look, we have found right away where these two meet. The intersection point of these two graphs. But this time, it's negative 3. So once again, let's realize that our slope equals rise negative 3 over run. Okay? So we will go down 3, 1, 2, 3, and over 1. We have our 2 points. Can now sketch this out as best as Mr. Wagner can. Ooh, that's bad. Let's try that again. There it is. I don't think I'm going to be using this program anymore because this is not easy. You're getting the picture though. We have the intersection point. We can easily find a second point, and that helps us out. Wow. I really apologize. This is pretty terrible. Anyway, so that's a nice, easy way to graph two equations. Get them in slope-intercept form and graph away. I apologize for the sloppiness of this video, but it gives you all the basics you need to do these kinds of problems. And if you're looking for particular points on a graph, just use point testers, plug them in. We know that when x is 0 here, y is 1. When x is 0 here, y is 1. So that's the point that both of them share. If you want to find a point that's only on one graph, just plug in a different x value. So if I plug in x is 3, so whenever x is 3 here, y should be 7. Yeah, so I almost got that right. So y is 7. And that's how you can find a point that's on this graph, but not this graph, and also how you can find a point where they intersect, which is just solving a system of equations. All right, I'm getting long-winded now. I hope this helps you out. Ask any questions in the comments below. Thanks. Bye.